Nakong Hedi, computer a student here at Maka University, and I'm going to take you through machine learning. My friend will join in later. So, first of all, machine learning is a method of teaching computers to make predictions or decisions without explicitly being told how to do it. So, in this, we mean that computers find patterns in the data that it has been provided with and makes predictions and decisions. In that, instead of following written rules by the programmer, the computer learns the patterns in the data. Like in a traditional programming, the procedure could be that you study the problem, you write the rules, and then evaluate, then check for any problems. In case there are errors, you analyze the errors, then go back through the same process. When they are rectified, then we launch the model. But with the machine learning approach, we study the problem, then train the machine learning algorithm by feeding it with the necessary data. Then we evaluate the solution. Then in case of any errors, still we analyze the errors, then go back to the same procedure, and when the errors are rectified, then we launch. Then there are basically two types of machine learning, that is supervised machine learning and unsupervised machine learning. So with supervised machine learning, for it requires human-labeled data sets. With data sets, we mean data instances, for example, questions, and in this case, they are labeled. Labels are like answers. So they are needed to provide the necessary supervision to the model that is being created. So there are techniques in supervised machine learning. One, we have classification, which deals with discrete data labels. For example, the computer is able to classify the email sent to you, whether the email is spam or non-spam. Then another technique we have is regression. And this one deals with continuous data values. For example, a machine could predict the prices of a building based on the size or location features that it is fed with. And some of the examples of supervised machine learning, we have decision trees, we have support vector machines, like we're going to see later. So continue with unsupervised machine learning. For it enables machine learning without any supervision. There are no labels in this data, like you can see in that diagram. The machine is able to group the data accordingly. So some of the techniques we have this side is clustering. With clustering, it deals with grouping together features that have the same characteristics. For example, key means, it will be given in more details later. We also have dimensionality reduction. So this one deals with reducing the feature spaces, like reducing some features in the data that has been provided. For example, principal component analysis, and that will also be discussed. Another one we have is anomaly detection. For it deals with detecting unusual occurrences in data. For example, you could go to an ATM machine and you want to withdraw money, but the ATM is not yours. So the machine will detect unusual occurrences. For example, you may put in a wrong PIN and the card is rejected. So the key application we could give is customer segmentation in this case. Then with supervised machine learning, there are some concepts that need to be noted. For example, feature scaling. Feature scaling is just a pre-process step that is done before data is being fed to the algorithm, where features are normalized and all standardized when we are trying to bring them to the same scale. This is important because it helps to optimize gradient descent, and it also reduces the bias to the data, just in case the data has large ranges of features. Then another concept we look at is the data cleaning, and for it, it just involves preparing data by correcting or removing unnecessary or irrelevant data. It could be incorrect because a messy data would make the model perform poorly. Another concept to note there is feature engineering. In part, it involves transforming data into meaningful features to improve the machine performance, and that can be done through combining, removing, or adding certain features. So next, we have the model. A model is just a representation of some phenomenon, a situation, event, or we could say a concept, and it represents non-math stat models. In this case, we have two types. We have deterministic and probabilistic. Then with deterministic, this one hypothesizes exact relationships. What we mean by that, it gives clear and it is specific to certain variables. For example, when measuring body mass index, the machine uses the body fat, uses its width and its length. Then another type of another type is probabilistic. And with probabilistic, this one hypothesizing into components, basically that is deterministic and room of error. There are basically three types of probabilistic models. That is regression first. So with regression, this one predicts continuous outcome between variables that are independent and those that are exploratory. So some examples we could give here are simple and multiple, linear and nonlinear. So regression is divided into two, linear and logistic, in which linear is a straight line relationship, like we can see in the diagram down here. And then logistic, where it's a curvy one. It's not straight, and it's basically used in binary classification problems. So those models are in most cases used in forecasting and risk assessment problems or tasks. So another type we have is correlation, and this one measures the strength and the direction of the relationship between two variables. The correlation coefficient is ranges ranging from -1 to 1. And there are also other models, like we shall see later. Then this brings us to the k-nearest neighbor. The k-nearest neighbor, it is an algorithm. It is more simple and effective, and is used in both regression and classification tasks to predict outcomes by finding the k closest neighbor in the dataset that has been provided. So for it involves parametric and non-parametric models. So with the parametric, we always know the model, that which model exactly will fit the data. For example, the linear regression. And with non-parametric, the data itself tells us how the regression should look like. So for parametric, there is a defined number of parameters, and the other side, there could be any number of parameters. So the KKN algorithm involves steps, that is calculating the distance of the training data from the test point, and then finding the nearest k neighbors. After we find the nearest k neighbors, then we classify them, the point based on the majority vote. For example, we could say, like in this diagram, that the green element belongs to the red group because it has the majority vote. Then some of the use cases of KNN are text mining, agriculture, finance, and cargo competition. So when calculating that distance, we use two formulas. We either use the Euclidean distance formula or the Manhattan, like we can see in the diagram below. So we basically use the Euclidean when the properties of the data we are using is similar, and Manhattan when they are dissimilar. So that takes us to the pros and cons of KNN. So with pros, we can see that it's very easy to explain and simple to understand. Then does not require assumptions of the data distribution. Then can be used for regression and classification problems, and also multi-class data sets. They are easily used in that case. So the cons include its efficiency of the algorithm declines as the data grows bigger. So it is costly because of the prediction steps that are expensive. And it also suffers, skewed class distributions. Then it cannot work if there are many missing values in a data set. So next we have decision trees. So for the decision trees, these ones they predict outcomes by splitting data into branches like trees, like you can see in the diagram. And for the
Hello, my name is Namata Haula Mwenesha, Computer Science Year 2, and I'm going to take you through ensemble learning. So ensemble learning is a machine learning technique where we have multiple weak learners that are embedded into a supermodel. This is majorly done to improve on the general model's accuracy since we embed multiple learners in it. Um, Ensemble learning is done in two types. We have bagging. Bagging, this is where we create multiple independent models by training them on different subsets of the data. The data is created using bootstrap sampling. Some of the advantages of bagging is that it reduces overfitting and it improves on the general stability of the model. Then we have boosting. So in boosting, here we train the models sequentially. The models are trained one after the other in a sequence. So the current model corrects the errors made in the previous models. If you have models in a sequence 1, 2, 3, model 2 will correct the errors made by model 1, so on. Uh, so the major difference between bagging and boosting is that bag, bagging reduces variance and boosting focuses majorly on correcting errors. Um, in the next slide, I'm talking about some of the advantages and disadvantages of ensemble learning. So there's improved accuracy since we have multiple models. There's robustness in a way that ensembles are less likely to suffer from overfitting or underfitting. And then versatility, since since this technique, ensemble learning, is applied on a wide range of ML problems, there is reduced errors because we have multiple models, and when we have multiple models, the possibility of erring is low. And then uh, some of the disadvantages of ensemble learning, there's increased computational cost since we are training many models, and training each model requires time and resources, and then increased complexity. You can easily understand a model on its own, but it may be hard to understand and assemble, like to understand a collection of models. Then here I have an illustration showing ensemble learning. So we have the original data set, and then we via bootstrap sampling, we have a bootstrap sample 1, 2, 3. We sample the data set via bootstrap sampling, and then we feed the samples into the algorithm 1, 2, and 3. Uh, Algorithm 1, 2, and 3, and then these algorithms make predictions 1, prediction 2, prediction and 3, and then the final prediction is the overall prediction by is the general prediction by both the three models. And we have the random forest algorithm. The random forest, this works by we build multiple decision trees, and then we make the general prediction of the model is a collection or a major voting of of all the models. Sorry. So one of the advantages of the random the random forest the random forest algorithm is that we have a higher accuracy since we have many decision trees, and prediction prediction from the three decision trees would would outweigh if it were one. So then it is that resistant to overfitting due to the averaging in the randomness, and then random forests properly handles missing and imbalanced data, and then versatility since it works for both classification and regression tasks. And then the disadvantages of random forest: increased computational cost and less interpretability because you can easily understand one decision tree, but then if there are many, it can become complex. Then the support vector machine. The SVM is a supervised machine learning algorithm used for classification and regression tasks. So how does SVM work? It works by use of a hyperplane to separate the data into classes. And then after it makes use of the support vectors. How? The support vectors are the data points closest to the hyperplane and have the most influence on its position. Then it works by linear and nonlinear separation. And then with linearly separable data, SVM uses a straight plane. And then for nonlinearly separable data, it excuse SVM uses takes a I'm going to talk more about the kind effect in my next slide. Mm. So the Kano trick, this is this is this is a function that allows SVM to solve nonlinear data problems by mapping input features into a higher dimensional space. Kind of like for example here in my illustration, this is the input feature, and then the function, which is the Kano trick. It then maps these input features or our input data into a higher dimensional space. Some of the examples of kernels, the common kernels have the linear kernel, that is for linearly separable data, or we have the polynomial kernel, that is for polynomial relationships, the radial basis function, which handles complex nonlinear relationship, and the sigmoid function, which mimics the neural network's activation function. The advantages and disadvantages of the kernel: it is effective in high dimension, it is robust overfitting, it is versatile, since it handles both linear and nonlinear data. It is a sparse solution since only support vectors are used, making it memory efficient. And then the disadvantages is that it is computationally expensive, sensitive to parameter tuning. This makes it unsuitable for noisy data, and then it also struggles with overlapping. And then clustering. Clustering. Clustering is an unsupervised machine learning technique used to group similar data points. Because it is a machine learning technique used to group similar data points based on their features. For example, here in my illustration, I have 3 clusters. Some are in blue, green, and red. So these are data points with similar features. So this is what clustering does. It groups those with similar features together alone. So the key concept in clustering, we have a cluster. So these 3 are clusters, which is similar to one another. So the blues are similar to greens and the red. And then distance matrix, this is to deal with the Euclidean and the Manhattan distance. And then the centroid, which is the center of a cluster, used in some algorithms. And then clustering majorly has 3 algorithms: the K-means, DBS, and the GMM. So the K-means algorithm, in the K-means here we partition the data into K clusters into K clusters by minimizing the distance between their cluster centroids. That is how K-means clustering works. And then GMM, this one uses probabilistic models to assign points to clusters. Then the pros and the cons of clustering: there's improved decision making. Researchers, business owners can make use of the clusters and make better informed business decision. It is versatile since it is applicable to a wide range of data types. And then there's dimension reduction. This helps in working with complex data sets. And then the disadvantage with clustering is that clusters may be difficult to understand at times. And then there's a risk of overfitting, and then scalability issues, like many clustering algorithms struggle with large data sets. And then the last one is the principal analysis. This is basically a dimension reduction technique. It is used to reduce the number of features in a data set, but with an aim of retaining as much information as possible. How does it work? So principal component analysis works in 5 steps. So the first one, they standardize the data set. Here they center the data by subtracting the mean. That is how the data is standardized. And then they compute the covariance matrix by measuring the relationship between features to understand how they vary together. And then the third step is calculating the eigenvalues and the eigenvectors. The eigenvectors are calculated in the direction of the maximum variance. And then after calculating the eigenvalues and eigenvectors, you select the principal components. Since we have the eigenvalues and the eigenvectors, we select the eigenvectors depending on their eigenvalues, and then we order them from the large